Hello everyone, my name is Dan the Tutor. Now I just wanted to spend some time talking some more about limit at infinity questions, which again, those look like the limit as x approaches either infinity or negative infinity. It really doesn't matter which one. And then you have something in the numerator like 3x squared plus x plus 1 over x squared minus 4x minus 5, something like that. And these are classic limit at infinity problems. And the way we solve them is just an easy shortcut method. We're looking at the leading degree in the numerator and the leading degree in the denominator, and we're saying which one's bigger. And there's three cases we can have. We can have degree of numerator is greater than the degree of the denominator. And in that case, the limit as x approaches infinity is actually going to approach infinity, and we're going to say does not exist. So that's the first case. The second case we can have is where the degree of the numerator is equal to the degree of the denominator. And in that case, we're looking at the leading coefficients. We're looking at the leading coefficients. So in other words, if I have a limit as x approaches infinity of 3x squared over 5x squared, that limit is just going to equal 3/5. We're looking at the leading coefficients, okay? And then the last case we can have is where the degree of the numerator is less than the degree of the denominator. And when that happens, the limit is just going to equal 0 as our final answer. And so these are the three cases we can potentially have. And all you need to do is memorize these three rules, and you pretty much got down limits at infinity. It doesn't even matter if it's positive or negative infinity. It's going to be the same exact answer for all three. So now let's just look at some examples. Let's say I have the limit as x approaches infinity of 5x cubed minus 3x squared plus 10x minus 2 over x squared plus 3x minus 7. So now again, we're really just looking at the leading degree of numerator and denominator. We see it's 3 in the numerator, 2 in the denominator. The degree of the numerator is bigger than the degree of the denominator. And for that case, we're going to say does not exist. That's all you need to do. Just recognize leading degrees and then figure it out from there. Easy. Next up, limit as x approaches negative infinity of 4x squared minus 5 over 10x squared plus 3x minus 2. So again, we're looking at the degrees of the leading coefficients. They're equal to each other here, which means we just now need to look at the leading coefficients. And so our answer to this question is just going to be 4/10, or that's 2/5. Final answer. It's cool because we don't even need to do any real calculations here other than that, and it doesn't even matter that it's negative infinity. It's going to be the exact same answer. Let's keep going. More examples. Limit as x approaches infinity of x squared plus 10x plus 4 divided by x plus 3x squared minus 4x cubed. Now, what's the leading degree in the numerator? X squared. What's the leading degree in the denominator? It's going to be 3. I tried to mix up the format here because there's not a lot of ways to really mix up the material here. It's the same 3 rules every time. And so here, the degree of the denominator is bigger than the degree of the numerator, and for that reason, the limit is just going to be 0. Okay? Let's keep going. We'll do one more. Limit as x approaches infinity of 4x plus 3x squared plus 9 divided by 5x squared minus 3x plus 10x minus 2. And I can throw in as many x terms as I want, and it really doesn't matter. All that matters is the leading degree here. It's 2 and it's 2, which means we're looking at the coefficients 5 and 3. And so our final answer is going to be degree, coefficient of the numerator, which is 3, divided by coefficient of the denominator, which is 5. It's just going to be 3/5. Okay? I think you get the point at this rate. And yeah, that's pretty much everything you need to know about limits at infinity. Thank you all for watching, and I'll catch you next time. Bye.